Okay, today we're going to be talking about roots and radical expressions. Basically, we're going to simplify roots where we're going beyond square roots. Okay, so what do we already know? For example, everybody in here, you guys already know if I say the square root of 16, then you would say that answer is 4. Okay, but now today what we're going to do is go beyond that. For example, we're going to talk about, for example, cube roots. So let's take the cube root of 27. And just as a quick preview, well, what does that mean? Well, that means that this index right here, and we'll talk about this here in just a second, but this index is 3. We're saying what number times itself 3 times is 27? And that answer is 3. Okay? So that's the basic idea of what we're going to talk about today. So here we go. Let's go ahead and get started. Okay. So again, we're talking, we know square roots. Where cube roots is what number is multiplied by itself 3 times, okay, to get to that number when we simplify it and bring it out. And we can take this to generally, we talk about this index here, this n, and say we can generalize that as n times in that index. Okay. All right. So, well, what does this look like? All right. And again, this is the index. And I don't, it's kind of sad for you that to this point in your math life, they've never written anything there. When in reality, if I give you the square root of 16, this number here has always been here, and it's 2. What you're saying is what number multiplied by itself is 16, and you know that answer is 4, right? We could simplify that as 16 square root of 4 square root of 4. So that's 2 times 2 is 4, right? So we know several ways of simplifying those radicals. We've done that this year and in previous years. But now there's vocabulary and there's symbols here. So the vocabulary says what are all the real roots? In other words, the real numbers that make this happen. The cube roots of 0.027. In other words, it's saying what number times itself 3 times is 0.27. And that number is, in fact, for us, shoot, my symbol here, cube root there. So it is 0.3. How could I check that? Well, let's take a look. 0.3 times 0.3 is 0.09. Multiply that by 0.3 again, and I get 0.027. Okay? Let's take a look at another one. Negative 125. Okay? So the cube root of negative 125. Okay, so there's a negative number there, and typically before this time we'd say, okay, imaginary, imaginary. But now, think about this. There's a number here that is the answer that is a real number. All the real roots is what it's asking for. Today we won't use I in any of our solutions because we're talking about real roots. Negative 5 times negative 5 times negative 5 is negative 125. So that's the answer to the question, what number times itself 3 times is negative 125? Okay. The last one here, the 1 over 64, well, I have to do top and bottom separately. So the cube root of 1 over the cube root of 64. Well, what number multiplied by itself 3 times is 1? Still 1. What number multiplied by itself 3 times is 64? That would be 4. And there you have it. Okay? Cube roots. Cube roots. What number multiplied by itself 3 times is that number? Okay, there's the pretty version of that. Fourth roots. Okay, so symbolically it looks like this. Is there a number that multiplies by itself 5 times to get to 625? There is. There are actually two possible answers. 5 and also, look at this. -5 times -5 times -5 times -5 is also 625. So the, for real answers only, yes, there are two answers. -5 and 5. Two possible answers for that one here. Now, here's where I get stuck again. Again, today we're only talking about real answers. So fourth root, so my index is 4, -0.0016. Okay, doesn't matter what I could put in there. I could put -16, doesn't matter. But the bottom line is, if it's an even number right here, there's no positive or negative number I can put in there that's going to make that a real solution. Okay, you know, a negative point two won't do it. Positive point two won't do it, because when I multiply things together 4 times, I'm going to get a positive number. Okay. Now the 81 over 65, 625, again, let's look. So symbolically, it looks like this. Fourth root, 81 over the fourth root, 625. And we know the 625, we've already done this. So plus or minus 5 there. And on the top, 3 times itself 4 times is 81. So 3/5 and -3/5, excuse me, are your answers. Okay. Both of those will, in fact, get you, if you multiply that by itself 4 times, you'll get that number. Okay. 81 over 625. All right. So now what we're going to do is go ahead and add variables to this. Okay. So let's look at this. Okay. All right. So basically simplifying with variables here, we get uh, what's the index here that's implied but not written is 2. Okay. So basically, what times itself twice is x squared? Well, that answer is x. So basically, our rule for this is we're going to take the number, our exponent, and divide by the index. So our exponent over our index when we're talking about variables. Which leads us to quick examples here. This guy is 2. So 8 over 2, that means x to the 4th times itself is x to the 8th. Yeah, that makes sense. Y to the 12th, so 12 divided by 2. Y to the 6th, okay? So what we're saying here is this. Multiply those two together, and I should get x to the 8th, y to the 12th. And we do, okay? Let's look at this one over here. Now I'm going to take a cube root. What times itself 3 times is x to the 9th? Well, that would be 9 divided by 3. I didn't need that there, sorry. 9 divided by 3, so x to the 3rd. X to the 3rd. So again, divide the exponent by the index. Okay, now this one, we have a little remainder. So he's kind of stuck in there. Okay, so this is going to be 9 divided by 2 is 4. So x to the 4th. And I have a remainder of 1. Well, I'm going to leave that under the radical sign. Okay? So when you have remainders, you leave them under the square root sign, just like this. This compares exactly to this situation right here. It's exactly similar. Square root of 50. Break it up into 25 square root of 2. We say 5 square root of 2. Well, this square root of 2 is, there's no perfect squares that go evenly into that, so that's left under the square root sign. Same thing here with this x. There's no perfect squares that go evenly with that, so it's left under the square root sign. It's an exactly analogous situation. All right, so now let's put numbers and variables together and see what happens. Okay, this is a 2 here. So what number times itself is 9? Square root of 9 is 3. And x 10 divided by 2 is 5. Okay. Now, we have a special situation here, and I want you to write this sentence down. For even indexes, even numbers right here, even indexes, we use absolute value signs if the variable exponent divided by the index is odd. So this number right here is odd, so we use absolute value symbols. And on the next slide, I'm going to show you why. Okay, there's the pretty version of that. And here's the argument as to why that happens. Oops. Okay, why do we use absolute value? Basically, what we're going to do here is we're going to think, um, we're going to actually plug in a value for x. So if x is negative 2, let's just see what happens. Okay, if x is negative 2, well, negative 2 to the 6th is 64 right here. Okay, and over on the right hand side here, negative 2 to the 3rd is just negative 8. Okay, and then the square root of 64 over here on the left hand side is 8, and that's not equal to negative 8. That makes a problem. We have basically something that should work. Negative 2 should work in that setting, but it doesn't, because when you simplify that out, 8 is not equal to negative 8. Okay. Now over here, if I go ahead and say, well, make that an absolute value symbol instead. Now when I pull that out, look what happens. That saves us. Okay. Because what happens is right here, again, this on the left-hand side is all the same. And on the right-hand side, well, now the absolute value of negative 2 to the 3rd, negative 8, is actually 8. So this is what allows the statement to become true. Okay. So in this special case, okay, when we get a uh, an index that's even and we divide out odd, that's when you're going to use absolute value signs. Okay, that's the only time you're going to need that. Okay. Again, we'll talk more about this, I'm sure, as you come to class. Okay. But now look what happens with a negative, or excuse me, with an odd number here. Think about this. AB is my solution here. 3 divided by 3 is 1. 3 divided by 3 is 1. So AB is your solution. Okay. Well, if A is negative, or B for that matter, if A or B is negative, then the radicand is negative. In other words, when we had, let's say, A is negative 5. Okay. So that number now is negative 125 there. Well, we've already learned earlier in the lesson that the cube root of negative 125 is, in fact, negative 5. There's only one answer there that works, not two. So that's why with any of these situations, I don't need to go ahead and put those absolute value symbols. The only situation I'm going to have any problem which requires absolute value is going to be when the index is even and we divide out and get an odd exponent at the end. Okay? And when you walk in tomorrow, you're going to go ahead and do the quick check. So you can just do that when you come in tomorrow. But right now, our goal is what I want you to be able to do is simplify cube roots and beyond. Basically, third roots and fourth roots is what we'll be primarily dealing with. So we'll talk to you when you come in, and hopefully you have a great day. Bye-bye.